You ever wonder how a massive company, with offices in New York, London, and Tokyo, can have everyone accessing the exact same files at the exact same time? Well, the secret sauce behind all of that is the technology we're going to break down today, the Wide Area Network, or WAN.
I mean, think about it. A modern company isn't just one big building anymore, right? You've got offices all over the place, people working from home, teams scattered across the entire map. So, how in the world do you get them all to act like one single, unified team?
You've got your main headquarters, sure. But then there are branch offices in different cities, and now, more than ever, you've got folks working from their kitchen tables. The thing is, they all need instant, secure access to the very same resources, the same data, like they were all just sitting in the next cubicle over. And that, right there, is the big challenge.
And this leads us to the heart of the matter. See, each of those locations has its own private network, what we call a local area network, or a LAN. So the real question is, how do you securely connect all these separate little islands of activity when they're hundreds or even thousands of miles apart?
Well, the technology that builds those bridges is the Wide Area Network, the WAN. And to really get what a WAN does, it actually helps to first understand what it's not. And for that, we need to look at its smaller cousin, the LAN.
The difference is actually pretty simple, but it's absolutely crucial. A LAN is local. That's your office network, the one in a single building, or maybe a college campus. A WAN? Well, that's the connective tissue. It's what hooks all of those individual LANs together, usually by using services from a big telecom or cable company.
Okay, so how do we actually build this connective tissue? Turns out there are a few basic ways to do it, and each one has its own philosophy about how you should connect things over long distances.
It really boils down to two big ideas. On one side, you've got the dedicated connection. Just think of it like leasing your own private, always-open highway between two of your offices. It's just for you. On the other side, you've got a switched connection. This is more like using the public mail system. It's a shared network, and a path is only created when you actually need to send something.
So let's stick with that private highway idea for a second. A leased line is exactly that. It's a permanent, dedicated link that you rent from a provider. Your speed is guaranteed, the connection is on 24/7, and nobody else gets to use it. It is all yours.
And you can see exactly how that works here. You've got Branch 1 and Branch 2, each with their own internal network. That leased line is the special dedicated circuit that runs right through the service provider's cloud, creating a permanent, private bridge just between those two locations.
Now for the other approach, and this one, well, this is pretty much the foundation of the entire modern internet. It's called packet switching. Instead of trying to send one huge file all at once, your message gets chopped up into tiny pieces called packets. Think of each packet like a little postcard with an address on it. They all get sent out into the network, they find their own fastest route, and then they all get put back together perfectly on the other side. It's incredibly efficient.
And there are a couple other flavors of this worth knowing. You have circuit switching, which is just like the old telephone system. When you make a call, a temporary, dedicated line is set up just for you. And then there is cell switching, which is kind of like a supercharged version of packet switching. It uses these small, perfectly uniform packets, or cells, to move data really efficiently, which was a huge deal for things like early voice and video calls.
So, those are the big ideas. But what about the actual real-world tech? The nuts and bolts. Well, all of this is built on physical stuff that you've definitely heard of, and you probably use it every single day. First up, you've got DSL, or Digital Subscriber Line. This was a total game changer because it was a super clever way to send high-speed data over the plain old copper telephone wires that were already running into basically every building on the planet.
And in a very similar spirit, you have cable networks. Companies took the exact same coaxial cables they used to deliver TV signals and figured out how to cram high-speed internet data onto them too. It's called a hybrid fiber coaxial network, and it's super common.
So what's the foundation for all these services? Well, that's the really heavy-duty stuff, a technology like SONET. Honestly, you can just think of this as the global superhighway system for data. It's a protocol for blasting enormous amounts of information as pulses of light through fiber optic cables. This is the backbone of it all.
Okay, so we have our expensive private roads, and we have the shared public highways, but what if you could have the best of both? Well, that's where a really cool modern invention comes in and completely changes the game.
A dedicated leased line is fantastic, right? It's secure, it's reliable, but man, is it expensive. So what if you could get that same level of privacy, that same security, but without having to pay for your own private road? What if you could build a private tunnel right through the public highway system? And that is exactly what a virtual private network, or VPN, does. It uses some seriously powerful encryption to create a secure, private tunnel for your data that travels right over the public internet. To anyone trying to peek in from the outside, your data is just scrambled garbage. But between your two networks, it's a perfectly private and secure link.
And you can see it right here. The private network at Site A and the one at Site B, they don't have some crazy expensive dedicated wire between them. Nope, they just connect to the regular old internet. But the VPN software creates that secure, encrypted tunnel right through the middle, tying them together like they were plugged into the same wall.
So, this whole back and forth between physical and virtual connections, it leaves us with a pretty fascinating question for the future. As we all get more and more connected and our need for speed and security just explodes, what's the next big leap going to be? Is it going to come from smarter physical networks, faster fiber optic cables and better infrastructure? Or will it come from even more powerful virtual tools, like next-gen VPNs, that can create these secure spaces on top of whatever network already exists? That's the puzzle network engineers are trying to solve as we speak.